Let's do a problem from your lab assignment, section 11.8. This is problem number 3. Find the radius of convergence and the interval of convergence for the series 10 to the n times x minus 9 to the n divided by square root of n as n goes from 1 to infinity. So we will again use the ratio test. The ratio test takes the n plus first term and divides it by the nth term. And by doing the combination of simplifying and putting together the square roots as you take the reciprocal, you will have an n in the numerator and an n plus 1 in the denominator of your square root. We have n plus 1 tens in the numerator and n tens in the denominator. That will leave you with 1 10 in the denominator, and the same goes for x plus 9. So this 10 times x plus 9 is independent of n, so we can move that out and focus on the square root of n divided by n plus 1. We know that this limit n divided by n plus 1 has matching degrees of polynomial in the numerator and in the denominator. So that just has a coefficient of 1 divided by 1. And so that limit is equal to 1, and the square root of 1 is going to be 1. So the limit of that portion is going to be 1. So therefore, the ratio test is going to give us 10 times the absolute value of x plus 9 times 1. So according to the ratio test, this is going to converge absolutely when L is less than 1. And if we take a look at this and solving for this, let's see if we can quickly sketch it out. 10 absolute value of x plus 9 less than 1, we'll have x plus 9 absolute value is going to be less than 1/10. So this is going to give us a center point at -9. That's what makes the absolute value equal to 0. And then we're only going to move a small space of 1/10 to the left and to the right. So that is our radius of convergence. So let's go ahead and put 1/10 here for the radius of convergence. So now a little bit over to the left will give us -91/10. A little bit over to the right will give us -89/10. So we can mark those. -91/10, and then -89. This is an 8/10. So these are endpoints, and at this point, this is a question for us. Do these things converge or not? So we got the radius of convergence so far, and so that question is, are we going to include the endpoints? So if we put 89/10 first into our x values, we're going to get 89/10 89/10 plus 9. So 89/10 plus 9 is going to be, I believe, a 1/10. So we have a 10 to the n, and then 89/10, -89/10 plus 90/10 will give us a 1/10. Now they both have the same power, so we can put them under 1 power. And 10/10 is just 1. So this is just 1 to the nth power. Now 1 to the nth power is just 1 divided by n to the 1/2 power. So this is a p series with p equal to 1/2. And 1/2 is not bigger than 1. So this is going to have to diverge. This thing diverges, which means at 89/10, that's the right side, we must have an open circle. We will not shade this in. Okay, we're going to converge everywhere else. The next question is what happens to negative 91/10. So we do the same thing over here, and just to save us a little bit of time, this is going to be a negative 1 raised to the nth power, kind of like the same way we figured out the 1 to the nth power for the previous one. So we have an alternating series. It's a p series. And so if it's an alternating series, we want to make sure that the limit goes to 0 and the sequence is decreasing. So this is in fact decreasing because as n gets larger, the 1 over n gets smaller. So the fact that this is that satisfies the alternating series test, we're going to say that this is convergent. So now that we know that that's convergent, we can fill in this circle. And what does that leave us? That leaves us with an interval of convergence that includes negative 91/10 and goes to negative 89/10, but it does not include the negative 89/10. So we have a closed bracket on the left side and an open bracket on the right side, and that is our interval of convergence. Okay, I hope that helps.